Hey everyone, this is Brooks with Brooks Builds, and I'm here again for another video just for you, YouTube. We're going to be talking today about manually working with databases, specifically SQL databases, and something we can do to help protect ourselves, especially if we need to work with production. Now, I know what we're going to say. We shouldn't be connecting to production manually and mucking around with it, but every job that I've worked at, I've noticed it's just like at some point of time, it generally seems that we need to do something like that. And obviously, after the emergency is done, it's a good idea to set up systems so we don't have to do that again. But in the case that we need to work with production live, it's a good idea to know at least one of these tricks. So let's go into this specific one, which is using transactions when manually working with a database. Now, a transaction is, think of it like a series, a sequence of SQL commands. Now, we are talking about a SQL database here. So a transaction, when we normally use it, is a way to have a series of SQL commands. And if any one of them fails, the entire thing doesn't actually execute. So let's say that you want to create a user and you need to insert a bunch of data about that user into many other tables. And it can't just be a single command that does it. You need many commands that run independently. And of course, if the fifth command down fails for some reason, you want to clean that up. Well, enter the transaction. If the fifth command fails, the entire transaction rolls back and nothing happens to the database. Pretty nice, right? Well, we can do the exact same thing when working manually in a database. So that way we have time to sort of, fix things or just not do them at all if they're not working properly. Let's jump into it, and I'll show you what I mean working with, a local database. So here I have a Postgres database running on my local system. We have node tables set up for this. So let's go ahead and we'll use a transaction to create some tables. Now, there are, at least with Postgres, two different ways for us to create a transaction. One is just with begin. So we're going to use the begin keyword here, and that, begins a transaction. This is the Postgres way of doing it. Notice here we can tell that we're in a transaction because the asterisk pound symbol. Okay, well now we can just do normal series of SQL commands. So if we want to create a new table, so we can just do create table. I wanted to create something for cataloging pets that we have. So we need species, so we'll do species first. So species, when ID, we'll have a serial. Serial is going to have it's going to be a primary key. And I also want a name, which is going to be a varchar. We have cat and dog. That's not very many. Let's just give it 10 characters. Okay, great. And we'll also do another one, create table, pets. We'll have another ID, serial, primary key, a name, which this could be obviously a lot longer, so I'll just make this 255. And I also want the species ID, which is going to be an int, and we're going to say this references a species and the column ID. Okay. Perfect. Now I can inspect these and make sure that they're working. So if I take a look, we can see, okay, we have pets and species. I can even inspect the pets, for example, and confirm that it does have the foreign key constraint and that it's referencing species. Perfect. I'm still in this transaction though, so it hasn't actually taken effect with the rest of the database. Like anybody else who is connected to the database in a different connection isn't going to see this. I have this other connection over here in this other window. If I were to do a DT, no relations. The table, as far as these other connections exist, doesn't exist. So if I want to make this real now, I can commit it. And as soon as that's done, now we see this list of tables that we've actually created, which is awesome. This is great. Okay, so now let's start actually inserting some pets into the database here. And we'll use the other way to create a transaction, at least the other way as far as Postgres is concerned. But this is the standard way that SQL has. So like the SQL standard says that a start transaction is the way to, well, start a transaction. Begin is actually a Postgres way, and it actually says that it's essentially the same as start transaction. It just has some other subcommands you can do with it, but we don't really care for, well, the purposes of simple transactions like this. Okay, well, let's go ahead and start creating a transaction here. All right, so I want to do an insert into, let's create some species. I want just to put in the name, values, and let's, should I do this incorrect or not first? Let's do this as an incorrect first. So if I use maybe double quote by accident, for example, we'll say species cat here. It's going to say, hey, column cat does not exist. Oh, right. We need to use single quotes for these. But notice that the transaction is now in a failed state. So I'm just going to go ahead and void it all out, and we're going to roll back right now. So if we were like several, well, commands into it, we would have to start all over again from the beginning, which is actually a good thing. But it's just sort of like a heads up that once we're in that state, I would not continue working through it. I would at that point in time roll back and start over again. So let's do that. Do another start transaction. We will then do another insert into species, name, values, single quotes, cat. And let's do it again for dog. Okay, we have these two. If I want to sort of take a look at these, we'll do a table species and see, okay, we have a cat and dog ID 1 and 2. That's actually going to be important to remember those IDs, and not only for the insertion of the, well, our two pets. We'll get into that in a little bit later. Again, this hasn't actually affected reality yet for this database. So anybody who is trying to connect in and use this database will see the two tables, but won't see any data inside of these tables. All right, so let's go ahead and insert our two pets. I'm going to do an insert into pets. We want name and species ID. We have our values. Okay, name. Let's start with Zilby. And Zilby, well, Zilby is a cat, but I'm going to make a purposeful mistake here, and we're going to say 2 for the ID. And our other animal is going to be Ranger. Ranger is actually my parents' dog. I don't actually have a second pet myself. There we go. Okay, so we have 2 pets in here. Now, if I were to just do table pets, everything looks right? We have Zilby, we have Ranger. All the data looks to be correct. Species ID, it's hard to tell, maybe, like, especially if there's a large amount of data, if that's correct or not. So when we're doing these testing, we should actually test it properly. So we're going to do an actual select. So I want to select, let's do the name, and do name as pet name. And the other name, so, well, if I do name as pet name, this probably needs to be pets.name as pet name, and species.name as species from pets. And then we're going to join species on species.id is equal to pets.species ID. Okay. And when we look at this, it becomes really obvious that we have made a mistake. Zilby is not a dog. Zilby is our cat. Zilby would be really unhappy to be put into the system as a dog. There's no way he would like that. So we have clearly made a mistake. And this is the second part of where the transaction becomes really helpful. Now, of course, I could decide to just do an update statement, and therefore it's never been put in a database anything other than, well, what it should be in the end. But let's imagine that we're doing something extremely complex, like a lot of commands sort of back and forth. If we've made a mistake here, do we know exactly what tables that we need to update, or should we just start over again and make sure we're following the right, well, procedures? Like, I hope that we would have some kind of checklist that we're following as we're going along doing this, and then later on we can, script it. So we're going to go ahead and roll this back. So roll back. And now if we go ahead and do a table of, well, species, nothing is still in there. So that's great. Let's go ahead and start again. So we're going to do another start transaction. And we need to do our insert into species again because we undid the entire transaction that included the insert into the species table. So our name, and we have values, cat, and dog. Okay. Before we do anything else, let's go ahead and make sure that we know what those IDs are. So table species, and this is really interesting because the auto increment did not actually reset with that transaction. It's not part of the transaction. It's outside of it. So therefore, we now have IDs of 3 and 4 for cat and dog instead of 1 and 2. So something to be aware of is that you can't just blindly assume that it's still a 1 and a 2 when we're inserting, well, Zilby and Ranger. All right. Now that we know that, that's fine. Now, of course, if we're using UUIDs, we would have needed to look at that anyways, just to know what those UUIDs are. Okay, let's insert our actual pets. So insert into pet. I want name and the species ID. We have our values, and we're going to have Zilby and 3 for the cat. And for 4, we're going to have Ranger. Okay. And let's go ahead. I'll just copy this select statement we did before. I just want to double check that everything is looking the right way. And there we go. Okay, we have Zilby the cat and Ranger the dog. Everything looks good. So we're going to go ahead and commit this. Excellent. And now everything should be as expected. We can table pets, we can table species, and we have all the data sort of set in there. We've completed working with our database manually, and everything looks good. We can go ahead and mark everything good, and we're done. So in conclusion, we've used transactions to work with the database. It protects us from syntactical errors. So if you make a mistake in the middle of a bunch of different transactions, it doesn't, well, commit any of those commands in that one transaction. We do have to start over again, which is annoying, but also that can be a good thing. We know exactly what the database state is. We don't sort of have to remember like, okay, where we've created the species and we created one of the pets, but not the other one. We sort of know that. It also potentially protects us from logical errors, but only if we test everything that we've done. And we should be testing that ourselves, right? Right? All right. Anyways, hopefully this was helpful. Let me know if you want more of these sort of like the technical side of these type of videos, or if you want me to just sort of stay in the chatting about things land. So with that, have a great rest of your day, and I will see you next time. Bye.